like a friend of mine.
Okay. All right. So you want to skip down to any question, or you want to start from the beginning?
You can start from like the last, yeah, those ones.
Part two sample.
Yeah.
Okay. Let's see. All right. Let's take a look. Both complete both parts to this question. Rectangle ABCD below. Measure of the EDC is 38. Okay. So where's EDC? EDC is E is in the middle. D's okay. So this is your 38 right here. Okay. All right. Let's see. Measure of angle EDC is 38. Find the measure of each of the numbered angles in the diagram. Okay, so how do you know this is 28? How do you know this is 104? How do you know this is 82? How do you know this is 52? What and what's six? All right, start. All right, tell me how you figured out one of those.
Um, so I did 80.
Okay, so let's draw this again. Here's your rectangle. All right. A B. All right, all right, tell me how you did it. Okay, so the only thing they give you is this is 38, and they tell you that it's a rectangle, right? Rectangle. What do you know about rectangles?
Is it the opposite sides are equal?
Exactly, in length, right? So this length would equal this length would equal this length. Okay, what else do you know about a rectangle? What do you know about this angle right here? This angle right here, this angle right here, this angle right here.
They're all congruent.
That's true. Okay, they're all congruent. What else do you know? If they're congruent there,
The same?
okay, they're the same. And what number are they?
Is it 90?
90. Yep, exactly. So if this is 32 right here, how much does one have to be? 90 minus 38 is what? 52?
Yeah.
52. So this is not a 8. This is 52 then, right? 52?
Uh-huh.
Okay, so angle 1 equals 52 degrees, right?
Yeah.
Okay, so we're good there. What else do we know? Okay, so if this is 38 degrees, how much is this right here?
38 degrees
Exactly. Why?
because the inner corners are equal to each other. Is that it?
Exactly. See your center right here?
Yeah.
This length is the same as this length. So that means that this length is the same as that length. So what kind of triangle is that?
Isosceles triangle.
Exactly. So what do we know about isosceles triangles?
Two sides equals the same thing.
Okay, that's true. What else do we know? So this length equals this length. What else do we know? In terms of angles, what do you know about that angle and this angle?
They're the same too.
Exactly. So if that one's 38, no, angle 2 has to be 38 also. Okay. So here's our isosceles triangle, right? This is this. This is 38 here. This is 38 here. So how much is this one? That's angle 5. How much is angle 5?
Um, 38 plus 38,
Is 76. Yep. Then what?
180 minus 76,
Yep. Which is
One
how much?
104.
So angle 5 is, yeah, yeah, that one's right. So this should be a 3 right here. This looks like this, instead of a 2, that should be a 3 right there.
Yeah.
So angle 5 is 104. That one's good. 104 degrees. So we got 2, we got 5, we got 1. What else do we need? Angle, what are we missing? We're missing angle 3. What's angle 3?
Angle 3 would be 52.
Exactly. For the same reason, right? This
Yeah.
is the same as this. So this is the same as that. All right. So what was that? That was 3, right? 52?
Yeah.
52. Okay, that one. And what else? What are we missing now? We got 1, 2, 3, 5. What else do we need?
6 and 4.
Okay, so we know 1 and 3, so we know 6 then, right?
Yeah.
If this is 52, that's 52. How much is this one?
Um, 52 plus 52 equals 140. No,
104.
104, sorry.
Yep.
104 and 180 minus 104 is 76.
There you go. Good. All right, what are we missing now? We're missing 4.
Yeah.
Okay, how much is 4?
Um,
What do we know? Remember your Z pattern? What do we know about that right? Oops, right there. Oop, I didn't draw it too good. Let me draw it again. What do you notice about this right here? This angle. So there's your Z pattern, right? So this angle should equal this angle. Okay.
yeah.
So what is 4 then?
52.
There you go. Angle 4 should equal angle 1, which is 52. 5, 2. Okay.
Okay.
So 1, 2, 1, 2, 3, 4, 5, 6. Okay, we got all 6, right?
Yeah.
All right. It looks like you understood. You just maybe did some calculation error right there and a calculation error right there. Okay. All right. So measure in rectangle ABCD below. That's 38. Find the measure of each of the number to. Okay, we did that. We just did that. Oh, so okay. So take a picture of that or copy that down.
I have that.
Okay. Can I erase it?
Yeah.
All right. Okay. All right. Which one you want to do? B?
Yeah.
The diagonals of a rhombus measure 16 and 30. Find the measure of the side of the rhombus. Okay. Oh, so use Pythagorean there. All
Yeah.
right. So what does a rhombus look like again?
Like it's how do you it's like a slanted rectangle.
Exactly. Slanted rectangle. So there's one side. There's one side, something like this, like that.
Yeah.
Okay. So the diagonals of a rhombus. So here's one diagonal, and here's another diagonal. The diagonals of a rhombus measure 16 and 30. So let's say this is 15, this is 15, and this is 8. Remember last week we did questions like this, right?
Yeah.
Okay, so now what are we doing? Okay, so find the measure of a side of the rhombus. So we're trying to find that length and we're trying to find this length. So what you did was yes, exactly. Okay, now just keep going. This is right. Just keep going now. What's 225 plus 64? Just keep going all the way.
225 plus 64 is equal to 289.
289. Okay, so if that's well, don't forget this part actually. Don't forget the square root part.
Okay.
Okay. So what's the root of so what's C? C equals what?
C equals two
What's the root of
two
289?
289 is oh wait 17.
So 17 times 17 is 289.
Yeah.
Okay. All right, that's cool. Find the measure of a side of the rhomb. Okay, so there's your side, 17. And we remember that we know that this length equals this length, and this length equals this length. Okay. Find the measure of a side of the rhombus. So 17. Okay.
Okay.
That's B. Yeah, you're good on B. Just finish it off. You're doing pretty good. Just keep going.
Okay.
Which one are we on? C? No, there's no C. Oh yeah, there is C. All right, let's see what it says. All right. All right, see, a right triangle has a hypotenuse of 8. There's our 8. If the length of one leg is 2, there's your 2. Find the length of the other leg in a simplest radical form. Okay, so what did you do there? Just subtract it, right? Is that what you did? Oh, no, yeah, you could do it. Yep. 2 squared plus x squared equals 8 squared. That's right. 4 plus x squared equals 64. That's right. X squared equals 60. That's right. Just put x here. Just put x there and just put x there. This is right. That's right.
Okay.
That's right. Okay. C is good. Two. You want to do two, or you want to skip to another one?
Oh no, do two, yeah.
Okay. Complete the following using a formal two column proof. So you know how do you do the two column proof?
Hold on. Okay, so the way you do it is there's one column that's for statements and there's one column that's for reasons.
Exactly. All right. So statements on the left and reason on the right. All right. What's the first? What's number one?
Angle K is congruent to angle F.
Okay. And then what's the reason?
It's given.
Yeah, exactly. Okay, so this angle K is congruent to angle F given. What's number two?
FK bisects JG.
Okay, FK bisects JG. That's also given. JG, that's also given. Okay, now what?
Um, JH is congruent to HG
JH is congruent to HGY.
because it's a line bisector.
Line bisector. Yeah, definition of a line bisector, right? Yeah. Line bisector definition. Line bisector definition. Definition. Okay. Yep. So let's see here. We know that this angle is this angle, number one. We know that FK, where's FK? FK is this whole thing. This, there's your FK, is, no, it bisects JG. So what does that mean? That means that this equals this, right?
Yeah.
Which is number three, line bisector definition. Okay, so we're trying to prove that this triangle, the top triangle JHK is congruent to the one on the bottom. Okay, so what else can we say?
Um, Angle JHK and GHF are vertical angles.
So, okay, yeah, and they're equal to each other, right?
Yeah.
So angle JHK is congruent to angle, what was this one?
GHF.
GHF, vertical angles is the reason. Vertical angles. Vertical angles. Okay, so let's see here. This is an angle, right? Number one is an angle, right?
Yeah.
Number two is a side. And then what else can we say?
Number three is a side.
Uh,
No, an angle. An angle.
uh, Number four would be the angle. We don't need this one. We don't need this one. There's your congruency by ASA. So this would be number three. All right. So number four would be this would be number four. Scratch that out, scratch this out, and just say by angle, side, angle congruency. There's your angle. There's one angle. Actually, wait a second. Wait a second. Did I mess that up? Let's see here. We know this angle. We know this side. Actually, maybe we say HK is congruent to this one. Then we'll have angle, side, angle. Let's change J. Which one should we change? Do we know that HK is congruent to HF? Do we know that?
Um, HK is going to say HF.
Do we know that from this right here? FK bisects JG.
Yeah.
FK. So then we would say angle, side, angle. This would be the side here. This one would be the side. So this is number one. This would be number two by the same reason. Actually, let me scratch that out. Let me scratch that out. We want to say what should we say number two?
HK equals HF.
HK, yeah, or congruent to HF by line sector by what do you call it? Line bisector definition. Line bisector definition. And then three would be what? Line. So this is your side right here. This is the side right here. And then for three, that would be number three. This is the new number three on the bottom. And then number four is just the two of them are congruent by ASA. This is number three. And then number four is the actual statement. Triangle JHK congruent to triangle GHF by ASA. Angle, side, angle, congruency. Okay. So remember the ways to prove congruency. ASA. What else? Angle, angle. What else? Side, angle, side. Is there one more?
Yeah.
What's the last one?
You do angle, angle, side.
Angle, angle, side. Yes, those four. So it's got to be one of. Anytime you get a question like this, make sure you're proving one of those four. Okay.
Okay.
All right. All right. You got that? Take a picture of that or write that down.
I have it.
All right. All right. So, all right. Which one are we doing? All right. Four. You want to do four or three?
Three.
Three. All right. Let's see what three is. In the diagram to the right, rectangle ABCD is drawn. The diagonal AC with diagonal AC. Find find the length of AC. All right. So how are we gonna excuse me, how are we gonna find AC? How are we gonna find this distance?
Um, Pythagorean theorem.
Yep. Okay, so tell me what to write.
12 squared plus 16 squared equals c squared.
12 squared plus 16 squared equals AC, right? AC. So root of that, right? Root of that stuff equals AC squared. All right, 12 squared is 144. Do what's 14 squared? I meant 16 squared.
Um, 256.
And now add 144 to that. Is that 400?
Mm,
256 plus 144.
yeah,
All right, so what's AC then? What's the root of 400?
or no, 20.
There you go, 20. Okay, good on you're good on that one?
Yes.
All right, B if DAC, where's DAC? DAC if if angle DAC is 3x plus, so this is right here is 3x plus 11, that angle right here, and angle C equals, they're saying angle C. They mean the whole thing, I guess. They mean the whole thing. The whole thing equals 2x plus 9. Solve for x. Then find the measure of each angle. All right, so how are we going to do that one?
Mm, EAC equals 3. EAC equals 90. 2x plus 9 equals 90.
Okay, yep, that's right. Yep. Okay, so let's find that. 2x plus 9 equals 90. Okay, what's the next step?
Um,
Subtract 9 on both sides.
yeah. And
2,
2x equals 81.
81. Okay, so divide both sides by 2. So you get x equals 81 over 2. Okay, now what?
Um, I got a decimal.
Yeah, it's 40.5, right? 40.5 is the same thing, right?
Yeah.
40.5 is the same as 81 over 2. Now what do we do?
Um, plug it in.
Okay, so yeah, exactly. So angle C equals 2 times, well, actually, we already know angle C. It's 90, right? Angle C equals 2 times 81 over 2 plus 9. So the 2's will cancel right here. So what's 81 plus 9? We already know that's 90 degrees, right?
Yeah.
So angle C equals 90 degrees. That's one answer. So how do we find out what the other angle is? How do we find out what DAC is?
Plug that one in too.
Exactly. So angle DAC equals 3 times 81 over 2 plus 11. All right, so what's 3 times 81 divided by 2?
3 times 81. 3 times 81 is equal to 243. And you said divide by 2.
Yep, then divide by 2.
121.5.
121.5. Now add 11 to that.
132. No, 131.5.
131.5 degrees, right? Degrees. Got it?
Yeah.
So the idea on that question is just solve for x and then plug it into both of them. Okay. Any
Yeah.
questions on that one? You good on that one?
Yes.
All right. I can erase this. All right. All right. You want to do 4? All right. 4, answer both parts. Find the length of BT and AT in simplest radical form. All right. How are we going to do that one? Okay. So length of BT. So, okay. So this length, that length right there. How can we find it? Can we use a trig ratio?
What'd you say?
We're on 4A, right? 4A.
Yeah.
So they're asking us to find this distance right here. This distance right here. How can we find that distance?
Um, is it equal to AB?
How do we know that? It's not. No, no, it's not. If it would be equal to AB if we knew that this length equals this length, but we don't know that.
Isn't it? This is a 45, 45,
Oh
90
no, no,
triangle.
no, my bad, my bad. You're right. You're right. My bad. You're right. Yeah, you're right. You're right. Good eyes. Okay, so x has to be, yeah, x equals 8 then. Yeah, you're right. This is 45, so this one has to be 45. So if it's the same angle there and there, then it has to be the same distance here and here. All right, so what about AT? Where is AT? Oh, okay. They want the hypotenuse. So how do we find the hypotenuse?
Is it you make it in, it says radical form, so you put 8 radical 2, I think.
What do you mean 8 radical 2? Like that?
Yeah.
Where is that coming from?
Because it says to find the length of BA and AT in simplest radical form.
Just use the Pythagorean theorem. 8 squared. Okay, so we're gonna say AT squared. AT squared equals 8 squared plus 8 squared. 8 squared plus 8 squared, which is what? 64 plus 64 is 128. 128. Okay, now simplify the 128.
Like in radical form.
Reduce it in radical form. What's the biggest perfect square that goes into 128?
That's a decimal.
It is a decimal, but they want it in simplest radical form. No decimals. We,
How do
we want to break it into two radicals. What are those two radicals? 64 and what's this one?
64?
What's this one right here? What's 128 divided by 64?
Um,
2. So yeah, you're right. 8 root 2.
because
But how did you get that? How did you know that right off the top? How did you know that right away?
I just did 8. That's why it was 8 over there. Like BT and AB equal 8. And I just put 8 radical 2.
But where's the radical 2 though? How do you know to write that right off the bat?
I don't really know. I just
You're just that smart. I guess, maybe, yeah, you're just that smart. But what I'm saying is, just show the work, right? Just show those steps in there.
okay.
You were right. That you got the right answer, but just show the steps. The school teachers they want you to show the steps, right?
Yeah.
All right, so just show the steps. So there's your 8 root 2. Okay. All right, so for part B, what are we doing? Find x and y on this one. Okay, so x is right here, y is right here. Okay, so how are we gonna do this?
Are we finding X or are we finding Y?
Doesn't matter. We know this is 60. We gotta find them both anyways. We know this is 60. How can we find x or y?
For X, 4 radical 3 divided by radical 3, and then it gives you 4. So 4 equals X.
Okay, say that again.
What I did was I did because um the one on like the 30 angle is 4 radical 3. So I did 4 radical 3 divided by radical 3, and it gave me 4.
How do you know where is this one coming from?
This is the way my teacher taught it to me. If it was a radical 2, you put it over a radical 2.
You put it over radical 2?
No, wait. Hold on. I need to like I remember most of the stuff that I did.
Have you
And
guys
she went
studied trig? What grade are you in? Six?
9.
Nine. Have you guys studied trigonometry?
No.
No? Okay. All right. Tell me how we can do it.
Um, yeah, and the 3 and the 3 cancel each other out and you just get 4.
That's true. That's true. But my question is, how do we know to write that?
Because the 4 radical 3 is radical 3.
Your teacher taught you how to do it like that?
That's what I remember.
Okay. All right. Okay, that's fine. Okay, so x equals 4 is what you're saying, right?
Yeah.
Okay. All right. So what about the y?
For Y, I did 4
Yeah.
times 2.
4 times 2
Yeah, I got
or 4
8.
squared?
4 squared, yeah.
Yeah, 4 squared, yeah. Plus
4 squared.
y equals just okay, so if this is 4, just use your Pythagorean. Y would equal 4 squared, y squared equals 4 squared plus this one squared, 4 root 3 squared, the root of that. Now simplify this root right here. 4 squared is 16, right?
Mm-hmm.
Plus what? What's 4 times 4? That's also 16. And root 3 times root 3 is what's root 3 times root 3?
6?
No,
Oh, 9. 9.
yeah, it's root 9, but then root 9 is 3, right?
Yeah.
So 16 times 3. So this one is 48. What's 48 plus 16?
48?
Well, the second one is 48, right? 16
Yeah.
plus 48. What's
Yeah,
16
okay.
plus 48?
64.
Okay, and then what's root 64?
Mm,
What number
8.
times, yeah, what number times itself is 8? I meant 64, which is 8. So you've got y equals 8 and x equals 4. Okay,
Yeah.
good on those ones.
Yep.
All right. These questions, just remember your Pythagorean theorem. Just remember your what else are we using? Pythagorean theorem and well, that question is mostly Pythagorean theorem. Let's play a game where you get to. All right, which one you want to do now? All right, that was one, two, three, four, five.
Yeah.
Find the length of PM and UM in simplest radical form. Okay, so same type of question. All right, so we're looking for PM, which is the vertical distance, and UM, which is the horizontal. So if that's 60, this has to be 30. Okay, now what?
What I did was I did 10 divided by 2, and I got 5, and I put down the 60.
Okay, okay. So this is 5, and then you put the 5 here or you put it here?
I put it on the PM.
Okay. Why would this one be 5 and not this one be 5? Why would it be the horizontal distance, not the vertical distance?
The way I remember is that you usually put the radical on the 30 side and then the not radical on the 60 side.
Okay. All right, tell me what. Okay, so you're saying the 5 goes here?
Yeah.
All right, so what's the horizontal distance? So you're saying
Mm,
this is P. You're saying this is PM equals 5, right?
yeah.
Okay, so what's UM?
5 radical 3.
Okay, how are we getting that? How are we getting that?
Um, I don't know. It's just
You're just that brilliant. You're just that smart.
I like
You
know
could
how
be
to
that
do.
smart. You could be that smart. I mean, the question a couple questions ago, you were that smart.
Oh,
I just want to know, like, if I'm looking at this, where is that coming from? So if we say that this is 5 root 3, remember, if we square this and we square this and add them together and take the root of that, would that be 10? I think so. Let's check. Let's check. So
okay.
if we use our Pythagorean, we can say that 10 squared equals 5 root 3 squared plus 5 squared. Is that 10? Or is that 100, I should say? What is this? What is this one? We know this one is 25. What's the first one?
25
Times.
radical 3.
Exactly. So what's 25 times 3 plus 25
25 times 3 is 75,
plus
and
25?
75 100.
There you go. So it does work out. It does work out. Okay. Yes, you're right. You are that brilliant. You are that brilliant. Yep, you're right. You're right. Okay, so there's your two answers.
Okay.
So tell me again, just tell me how you got the 5 root 3 on the bottom there. She said, well, your teacher just told you to follow a general rule.
Yeah. I
Okay.
think it's like the 30, 60, 90 triangles always have root 5, and the 45, 45, 90 triangles have root 2.
Yes. Yep. You mean root 3. On the 30, 60, 90, it's root 3.
Oh yeah, yeah.
Yep, exactly. Exactly. Good, good. You're on your way to some A's, Jalen. All right. B. Find A and B. Okay,
Um
so we know that. What do we know automatically? What do we know?
that A equals 6. Is it A? No, no, sorry, sorry.
No.
Um, no. You have to do like what do you mean? What do we know automatically?
Okay, we know this angle's 45, and we know this angle's 45. That's given, right?
Yeah.
So if it's the same angle there, then what kind of triangle is it?
45, 45, 90.
Yeah, yeah, that's true, but I mean, In terms of
Isosceles.
like isosceles, scalene, obtuse, acute, what kind of triangle?
Isosceles.
So what do we know about isosceles? This side equals this side. So we
Yeah.
automatically know A equals B. Now the question is, what is A and B?
The way I did it was I did 6 over radical 2 times radical 2 over radical 2.
Why are you multiplying by radical 2 over radical 2? I'm not saying it's wrong. I'm just asking.
This is the way my teacher told me how to do it.
Okay. All right. So what cancels here?
The radical 2 and the radical 2.
What's the bottom now? Yep, that's right. What's the bottom?
2,
Exactly. And then what's on top?
6 radical 2.
Okay, now reduce it. 6 radical 2. Can you reduce this?
Yeah.
What is it? 3
3 radical 2.
3 radical 2. Yep, 3 radical 2. This is A and B. Okay.
Okay.
Yep. Good. All right. 6. Complete the following using a 2. Okay, so all right, so just like the one we did a few minutes ago. All right. Given DB is perpendicular to AC, DB is perpendicular to A. So we know there's 90s right there, right?
Mm-hmm.
Prove that triangle ABD, the one on top, is congruent to the one on the bottom, CBD. Okay. All right. So on the right, we'll have reasons. On the left, we have statements. All right. Tell me what to write.
DB is,
Perpendicular,
yeah, perpendicular to AC.
given. Okay. That's given. That's number one. What's number two? Okay, so
Um,
that's DB. Are we going to say, so what is this? What are we going to say right here?
BD bisects ADC.
Say it again. BD bisects ADC.
Yeah.
Okay, so what else do we know then? From this, okay, so you're saying that's number two, BD bisects ADC.
I didn't put that down as number 2 though. I had a different one for number 2.
It's okay. You could have it. Could still be right. What did you have for number two?
I had ABD and CBD are right triangles.
Okay, exactly. Okay, what's the reason?
The perpendicular lines form right triangles.
Exactly. Okay. So then that would be what angle? What you just said would be angle, right?
Yeah.
Okay. So Which way did you prove it? SAS or what?
Yeah. SAS.
SAS. Okay. So tell me the.
Wait, that
Tell
was the
me
wrong
the
one. That was the wrong one. I had
which
ASA.
a angle side angle.
Yeah.
All right. Tell me the. All right. All right. So. All right. Tell me the order. Tell me like. So then you're saying the first one has to be an angle then, right?
Yeah.
All right. So tell me what number one is.
Number one. Okay, I think it's like my teacher's a little different. She teaches it like you have to use like the diagram instead of the statements.
The diagram. Yeah, you can use diagram. Yeah, that's okay.
That's how I did it. And my statements are like in order.
Okay, that's okay. Tell me your statements in order.
My first one was DB is perpendicular to AC.
Okay,
The,
that's
se-
given.
the second one was ABD is equal to CBD.
Okay,
Are
hold on.
right.
Okay, so you're saying what was the second one again? Angle.
ABD and CBD are right triangles.
Are you talking angle or are you talking triangles?
Oh, right angles, sorry.
So angle ABD, ABD is CBD is equal to angle or congruent to angle CBD, right?
Yeah.
And this was what was the reason again?
Perpendicular lines form right angles.
Yeah, perpendicular lines. Okay, so and then three would be what?
This one was like a proof for number two. It was just ABD is congruent to CBD.
ABD is congruent to CBD. Well, that's what we're trying to prove, though.
Yeah.
But we need one more thing, though. We need angles. We need angle. So we're going to say angle. This angle is equal to this angle. This side is the common side, and then this angle equals this angle. There's your angle side angle. Angle right here, side right here, angle right here.
Yeah.
All right, so let's rewrite it in that order. We don't even need these two. We don't even need that. Let's skip that. Let's go to number one. Let's say oh no, this the number two would be number one. Number two would be number one. So this is the real number one right here. This is number one. So this is perpendicular lines form 90 degrees. Form 90 degrees. That's number one. What's okay? So this is what? This is angle right here, right? Angle.
Yeah.
What's okay? What's the side? This one will be side.
This side was BD equals BD. Was
Uh,
congruent to BD, sorry.
BD is congruent to BD, and what's the reason?
Reflexive property.
Yeah, or just common or reflexive property. Okay, and then give me the last angle.
Um, ADB
Yeah,
is
exactly.
equal to CDB.
Angle ADB, right? ADB
Yeah.
is congruent to what?
CDB.
Yes, CDB. And what's the reason?
An angle bisector definition.
Yeah, exactly. Definition of angle bisector. Definition of angle bisector. And then four would just be what they're asking. Therefore, for triangle ABD congruent to triangle CBD by ASA congruency. ASA congruency. Okay.
Okay.
Make sense?
Yeah.
All right, cool. All right, so take a picture of that, or oh no, you already have that, right?
Yeah.
All right. All right, so that was six. And when is your test again? Tomorrow?
No, I think it's on Tuesday.
Tuesday? And when did you get this review? Today?
I I got it yesterday.
Yesterday? Okay, so we did okay, let's do seven. All right, let's do seven. Answer both parts. In diagram below, altitude AD is drawn to hypotenuse BC. Okay. If BC equals 42 and BD equals 6, find the measure of AB using a proportion to the nearest tenth, which is one decimal place. All right, so let's label BC is 42. This whole thing is 42, right?
Mm-hmm.
They're telling us that BD is 6, so this is 6. What's DC?
42 divided by 6 is equal to, oh, so 42 minus 6 is
Yeah.
equal to 36.
Yeah, 36. Okay, so we know those two measurements. Do we know anything else?
That's it.
That's it. Find the measure of AB. So we're looking for this distance right here. All right, so how can we use a proportion to set it up?
Um, hmm. I use mean proportion.
Okay, tell me what to write.
42 over x equals x over 6.
42 would be the whole bottom. So
Yeah.
42 over what?
Over x.
40. So you're saying that this is x right here?
Yeah.
Okay, so 42 over x equals what?
X over 6.
Okay, x over 6. Okay, so we have the big triangle, which is this, over the over AB, which is that. Then you have so big triangle over x, the base of the big triangle over x, and then you're saying x over 6 or 6 over, or should it be 6 over x?
It's x over 6.
Why do you have x over 6?
Because my teacher, she gave us like a shortcut, I guess. She said it's like HLLP and it's hypotenuse, which is 42
You
over
said HLLP. What does that mean?
hypotenuse, leg, and then like the half thingy.
What is this one?
B, it's like part, like half.
Oh, okay. So 42 over x equals x over 6.
Yeah, the half of 42.
Half of 42 is 21, right?
No, like I mean like because like they gave us that BD equals 6
Yeah.
and BC equals 42. And that was like the one half of the 42.
One half of 42 is 21, though.
No. I mean like the way they put it, like one side of 42 was 6 and the other side was 36. But the one that they gave us was 6, so we used 6.
Okay, so you're saying that you guys did an example like this in class?
Kind of. I use like my notes based off to
Okay.
like
All right, so if we were to solve this, we if we cross multiply, we'll get x squared equals what's 42 times 6?
252.
252. And then
Yeah.
so what's x?
15.9.
15.9. Okay. All right, let's finish B. Let's do B. In the diagram below, altitude AD is drawn to hypotenuse BC. If DC equals 25, there's 25, and BD equals 8, find the measure of AD to in simplest radical form. Okay, what's the proportion here?
I also used mean proportion for that one too. I did 8 over x equals x over 25.
X over 25. Okay, so you're saying BD over X is AD. 8
Mhm.
over X equals X over 25.
Yeah.
So then X squared equals 8 times 25 is 200. Is that right?
Yeah.
So X equals what's the biggest perfect square that goes into 200?
102.
Exactly. So this is no, what was that? 25?
Yeah.
Okay, so break the 200 into 100 times root two, one root two, root 100 times root two. So what is x?
10/2.
10 root two.
Oh yeah.
10 root two. Yep, there you go. Got it?
Mm-hmm.
All right, so your test is on Tuesday. Are you getting more review questions next tomorrow or on Monday?
No, I have a test tomorrow and on Monday.
You got a test tomorrow and Monday?
Yeah, it's like two tests a day.
Two tests a day or two tests in consecutive days?
It's two tests a day. I have six tests in totals, and we do two tests each day.
Okay, so what did we do? What did we do today? We did okay, so we did what, the second, was that the second page? Yeah, part two sample questions. That's what we did. One
Yeah,
through seven. We did one through seven today. All right, and the section part one you did already?
yeah,
Or you guys did that in class?
yeah.
Okay. So you good for today?
Yep.
All right, just keep putting the work in there a little bit every day. I mean, that's how you get great. You're already great. You're already great. Just keep putting the practice in,
Okay.
and you'll be even greater. Okay.
Okay.
All right. Did I tell you about the YouTube channel? I filmed
Yeah.
this and then I put it on the YouTube channel. So if you want to watch it, did I ever send you the link?
Yeah.
I did. All right. So I'm gonna post it on the channel, and then if you want to watch the replay, just watch the replay. Right?
Okay.
Okay, Jalen. I'll talk to you later.
Okay, bye.
Good luck tomorrow. Good luck Monday.
Thank you.
You'll be okay. All right. See you.